Okay, so get this, right? Our breath, like just breathing, could be like a secret window into our health. It's crazy. And you guys sent in a ton of research on breath sensors.
Yeah, it's pretty wild stuff.
So we're going to do a deep dive, see what this tech can really do, like revolutionize healthcare and stuff.
It really is fascinating. There are so many different ways they are approaching it. Like, we're not talking about just one kind of sensor.
Right. So many different sensors. So like you've got your basic ones, you know, the ones that like directly touch your breath, like
Yeah.
those airflow detectors, chest movement trackers. Oh, and like the pulse oximeters. Remember those? Everybody had those a while back.
Exactly. Those are all contact sensors, but then there's a non-contact sensors, and those are even cooler. I mean, they sound straight out of Star Trek, using things like optical beams and radar to like measure your
No
breathing.
way. Like lasers.
Well,
Yeah.
maybe not lasers, but yeah, similar idea.
That's awesome. And then you've got the wearables, right?
Yeah.
Patches, masks, clothing, you name it, all with built-in sensors to track your breath,
Mhm.
like constantly.
And we can't forget about the eNose devices. They're using all these fancy gas sensors to sniff out, literally, the volatile organic compounds in your breath.
VOCs.
Yeah, VOC.
VOCs.
Yeah.
Okay, so VOCs are like
Was-
chemical fingerprints?
Exactly. Think of it this way. Your body is like a giant chemistry set, always reacting, always producing byproducts. And some of those byproducts end up in your breath, see?
Okay.
Different patterns of these VOCs can actually point to different health conditions. Like if you have diabetes, you might exhale more acetone, or folks with asthma might have higher levels of nitric oxide in their breath.
Whoa, so like doctors could like diagnose you just from your breath.
That's the idea.
Wow. Okay, but like how do these sensors even work? Is it magic?
Well, some use these things called metal oxide sensors. So
Ah.
basically, they change their electrical conductivity when they come into contact with certain gases.
So they're like tiny little chemical detectors.
Yeah. Exactly. It's pretty amazing how they've managed to miniaturize all this super complex technology.
Totally. Okay, so we've got all these crazy sensors. What can we actually do with them? Like what are some of the real world uses for this stuff?
Well, one of the most exciting areas is cancer detection. There's research showing that breath analysis can catch certain types of lung cancer like super early.
Really?
Yeah, like with 80% accuracy in the early stages.
Wow.
And that's huge, right? Because if you can detect it early, there's a much higher chance of beating it.
Absolutely. I mean, that's amazing. So early detection of cancer, what else can this stuff do?
Think about chronic conditions like asthma or COPD.
Oh yeah.
Continuous monitoring could be a game changer for folks with these conditions, helping them manage their symptoms and prevent those really bad flare-ups.
So it's all about like giving people more control, right?
Exactly. And remember during the pandemic when everyone was talking about rapid testing?
Yeah.
Well, breath analysis was being used for rapid COVID-19 screening, and it could have a huge impact on other infectious diseases too.
It sounds like this breath sensor technology could be used for so many things.
Yeah.
Like it could really change the whole healthcare landscape. What's next for breath sensors?
Oh, the future is wide open.
Yeah.
One big area is miniaturization. I mean, we're talking sensors so tiny you could integrate them into everyday devices.
Like what?
Your smartwatch, your smartphone, you could literally have your devices analyzing your breath all day long.
That's insane.
It is, right. And AI, don't forget about AI. That's playing a huge role too.
Artificial intelligence.
Yeah.
Yeah.
It can analyze all that data from the sensors,
Yeah.
like way faster and more thoroughly than any human could. It's basically like having a supercomputer dedicated to understanding your breath.
Wow. Okay, this is all blowing my mind.
Mhm.
But like any new technology, there's got to be some challenges, right?
Mhm.
What are the hurdles we need to overcome before we can really see this breath sensor tech become mainstream?
Of course, accuracy and reproducibility are at the top of the list. I mean, we ought to make sure these sensors are reliable.
Yeah, like you want to be able to trust the results they're giving you.
Exactly. And then there's real-time analysis. That's super important, especially in critical care situations. We need those results instantly.
Makes sense.
Oh, and another big one is sensor specificity. We need to develop sensors that can zero in on specific biomarkers with really high accuracy.
Okay, yeah. So like more targeted sensors.
Exactly. And then, of course, we need standardization and validation across the board. We got to make sure that everyone is on the same page when it comes to collecting and analyzing breath samples.
So like clear protocols and rigorous testing.
Absolutely. That's the only way to make sure these diagnostics are really effective.
It sounds like a lot of work still needs to be done, but the potential payoff is huge. I mean, just think about it. Our breath, something we do without even thinking about it, could hold the key to a deeper understanding of our health.
It's pretty amazing, isn't it?
It really is. And as this technology keeps getting better, I think it's going to make us rethink our whole idea of health and wellness. Like,
Yeah.
what does it really mean to breathe?
That's a really good question. And I think it's one we're going to be grappling with more and more in the years to come.